happened? Because the play was this past weekend and they didn't have time to tear down. So then they needed
We
to tear
took
down.
down yesterday in class.
There you go. So that's when they did it. All right, kiddos. Let's go ahead and check our 10.6. We're not checking 10.7 yet for obvious reasons because it's not due yet. This would be helpful. Oh, yeah.
Didn't even have this spiral to this class.
He was thinking AP.
So I guess we know that Tyler didn't do his homework.
He did drop by, but you're still a good person.
Would you have done it if you had the spiral?
That is the question. Okay, you guys ready? 10.6, we're gonna go ahead and check, and then 10.7, we're gonna keep going on. We're not gonna finish today, we're gonna start today, finish tomorrow. But hopefully we'll get through most of it today, so that tomorrow we can finish, give you guys some homework time. The quiz is on Thursday. Just trying to dig into it. So the quiz is on Thursday, just 10.6 and 10.7. Just 10.6 and 10.7. You'll probably be able to use your calculator on the whole thing, but you have to understand some things in order to be able to do the quiz. Does that make sense? Use your calculator, you have to understand your mode and how to graph in your mode with parametric and polar, but if you guys have been absent, if you missed for AP, etc., Thursday is Gov, which is seniors, which shouldn't really be many of us. So therefore, we are here and we are taking it. So even if you're going, well, tomorrow's English, which is seniors also. Hey, cool. We get almost all of you guys tomorrow. And Thursday. Let's go ahead and just jump right in because we have a shorter class for today. You guys can already see numbers 14 and 28. Numbers 14 and 28. Parametric mode. When you graph, what should you be showing beyond just the graph? What are the arrows called?
Oh, the direction or
Orientation.
It's orientation. Orientation. It's the direction, the orientation. But you're right, it is the direction. It's just the orientation. It's a spiffy way. And it might be like the entire graph that we would normally graph, or it might just be a portion. So if it's parametric and they give you like a T range, and PS kiddos, on the quiz there will be a set of parametric equations and a table being like, hey, fill in the table, graph it, and show me the orientation. For parametric, should you show me little arrows and say, yay, forever? No, time is going to cut it off. Time is going to cut it off. It doesn't go on forever. Couple more seconds. Oh, can you guys also see the eliminating the parameter for each of these two? I forgot there was a part B. For each of them, you have eliminating the parameter in part B. I'm going to go ahead and zoom in on that because the graphs are up above and you guys can see that pretty good. So let me go ahead and zoom in on part B. Can you guys see them? So on the left, it was pretty easy. Solve for t, plug in to the other equation, and then you have x squared plus 6x plus 9. On the other one, now, if you used our notes, you might have been able to say, hey, isn't that an ellipse? And you might have jumped straight there from the notes. But technically, how would you actually solve it? What we said in class was isolate the trig function, so we got the cosines and sines alone, then squaring both sides, then add the two together. I know they don't show their work so good, but they got cosine and sine alone, they squared both sides, they added the two together, and what is cosine squared plus sine squared? Got it. So it's a little bit harder than the one we did in class, but it follows the point.
For an ellipse, how would you know the
Center? No.
orientation direction?
Ooh, good question. You would have to think about your angle values. You would have to think unit circle. So if you were actually graphing it, now the nice thing is if you look up here, they did the table first, right? So it wasn't a shocker. So they went ahead and figured out, hey, start at 7, -6, and that was wherever down here. And then they realized that as you kept going, you were going this way. Yeah. So you'd have to plug in a few angles at least just to figure out which way it's rotating. Caleb.
How did they figure out to do pi over 2? Who was that something you were supposed to know?
It was basically based on the equations. If you look at the equations, we have a cosine and we have a sine. Could you have done pi over 6, pi over 4, pi over 3? Yes. The problem is, why didn't they? Those are nasty because they have square roots in them. Like, maybe cosine will be 1/2 at pi over 3, for example. But sine will be root 3 over 2. So they didn't want to deal with decimals, so they were just like, ew, we don't want to deal with the weird radicals that show up for cosine or sine in different points, so they just chose the easiest ones. But if you had done more and had done decimals, maybe you would have gotten some of like the in-between points as well. Does that make sense, kind of? A little. But I just chose the nice pretty ones. And I think that ended up getting them, what did I get them? 7, -6, the 2, -2. That gave them the corners. And so then they just knew to do it in a rotation, in a rotating fashion within ellipse. But if you guys remember from yesterday, I also gave you, where were those ellipses? There we go. I also let you know, hey, these are always ellipses. So it was kind of like a hint from the equations. We still need number 44 and 58. 44 was just, hey, can you get this in your calculator? And I had a valid question earlier today. How do you put secant in your calculator again?
1 over
Cosine, good, 1 over cosine, right? So 1 over cosine tangent is just the tangent, but no big deal. And you just would have had to see, hey, can you get your zoom okay? So if you were in radians, just as an example, if you were in radians, then you should have had your T-min in your window be maybe like 0, and your T-max be maybe something like 2 pi. Yes, your calculator understands 2 times pi. Your T-step would have been something like maybe 0.1 or 0.2. That would have given you a pretty good picture. Guys, if your graph showed something like this, why should you technically not draw that? What are they showing you with that weird xy thing? Asymptotes, yeah. It's kind of freaking out. It's saying like, yay, oh no! Yay, oh no! Like it's just kind of freaking out in some of the older calculators, or even the newer ones. Kind of freak out and show the asymptotes, but technically it's just the hyperbola. That's the technical. If you were in degree mode, what changes? Just because I'm trying to, remember, say on the quiz, you have to be able to use your calculator. 0 is good, but instead of 2 pi, you guys help me, what should you put as your T-max? And then, do you remember that the T-steps are like the steps that you take to get there? So between 0 and 2 pi, between 0 and 6.28, I don't have super far to go, so I can go by 0.2. It's like, okay, it'll be a few steps. It'll take me a little while to get from here to there. But if I was to go, instead of like from here to the table by 0.2, if I was to go from here to like Lassen, do I want to go by baby steps? No. So instead of going by 0.2s, maybe I should go by like, I don't know, 0 to 360, maybe like by 5s. 5 is a little more manageable. Get lots of points. So it's not all weird and like trying to connect, but it's not going to take forever either. Did anybody have struggles with parametric graphing in their calculators last night? And then number 58, you were supposed to take the clues that they gave you and make an ellipse equation out of it, but as I showed you guys in class, there is a way of making parametric equations for an ellipse. And so you could have taken your h and your k, which I think or you had to find by finding the halfway point. And you could have just plugged in your h and your k. And then you could have found your a using the halfway distance or the half measurement between the two vertices. Remember, that's going to be the major radii. Take half the distance, and that's the 4. And then with your foci distance of C, you had to go find B's in the equation. So you had to go back to chapter 10, section, what was ellipses? 3, I think? You have to go back to 10.3, review a little bit. But using the formula I gave you in class, hopefully it wasn't too bad. Hopefully it wasn't too bad. All right, kiddos. Do we have any more? Is there more on the next page?
That's all?
Those are all the evens, but did you guys have any other questions on homework? 97, it was a beast, okay. Anything else besides 97? Is that the football one?
Yes.
I remember that one. Just 97? Going once, going twice? Okay. So let's go ahead and, let me get back to our notes. Do I have number, nope. Oh, I did number 97 ready. Number 58, I think I just pretty much talked through and no one asked me specifically for that one. So let's go straight to number 97. I don't even think they give you a picture, don't they just give you details? Can you guys help me out real quick? Someone releases a football, do they give you an initial height? What was it? Was it from the ground? I don't think it was.
No, it wasn't.
It was from some height. And then there's a release, and then it hits the ground down here somewhere. And there's the path to the football. So the quarterback lets it go. Anybody have any details?
Something about
So-
below 7.
And a height of 7 feet above the
Okay.
field.
So 7 feet is the initial height. It does say at the point of release, it is released at 35, is that what you're saying? 35 degrees is the angle at which it's released from. It is flying through the air. I think it asks about the maximum at some point. It asks about when it hits the ground at some point. It's asking about time. We are trying to get this in parametric equations, which means we somehow want to do an x and a y. Oh man, if only in the directions of this problem, or maybe the directions above this problem, it had you go back and look at earlier exercises with equations. What does it say for number 97? You can tell where this is my book and not yours.
See exercise in 93 and 94.
Exactly. So if you go look at 93 and 94. Oh, this is in 10.7, this is 10.6. And if you look above 93 and 94, because 93 and 94 just give you thetas and initial velocities, that's weird. But if you look above 93 and 94, they actually give you equations to plug in for. And the equation for x is v sub naught, which is initial velocity if you read the problem, cosine of theta times t. And the y is h plus v sub naught, sine of theta, t minus 16t squared. So you did not have to come up with the equations. They told you where to go look, and in that section up above, they gave you equations. But, we know something. What do we know that we can plug in?
Theta.
So I'm going to go ahead and plug in 35 degrees. We know the angle at which the football was released. Oh, we still want v sub naught, and we still want h.
No, height. 7.
Height is the, good, if you read the paragraph, the initial height, right? So where was it launched from? 7. Does that make sense with the receiver?
That's the tall quarterback.
Well, but when
Well,
you
no,
release, your hand's theoretically over your head, right? Like if you're trying to, so maybe, but still a talk, still.
Well, I mean, it's
still
like
But
6
still,
foot something.
I mean, 6'6" is-
It's like something, and then his arms extended, okay. You can kind of understand, they probably didn't wanna give us like
Probably shorter.
6.8 and like freak you guys out more than you already did from the problem. What else do we have? We don't have initial velocity. Well, that stinks.
Give up.
Is there anything else that we know? Wait a minute, what's the one point from the actual problem that I haven't put in? I said the initial height is 7, it's released.
30 yards down feet was 4
Yeah.
feet.
So 30 yards, now 4 would be, I don't know, down here somewhere, right? 4. So a receiver catches it 4 feet above the ground, 30 yards down the line, okay? So couldn't I say that's a point? So what's the x value for that? Now, I wish it was 30. But we're measuring everything in feet.
Oh,
So even though they gave us 30 yards, what do I need to, I know, it's struggle, huh? Even though they gave us 30 yards, I need to think about it as feet or a yard?
3.
Good, 3, so then 3 times would be 90 feet. So I have the point 90 for, isn't that an x and a y?
Both are calculated by initial velocity and then
There you go, it's a system of equations. Find the speed of the ball when it's released. Yeah, because you have 2 equations and you're gonna have 2 unknowns. So we could go ahead and say, we know un x and we know un y. We can go ahead and plug in un x is 90 and its y would be 4. It's a bit of a struggle because we can't just do like elimination or something and add or subtract, but we can still do substitution. So I suppose we could take this equation, we could solve for t. And t would equal 90 over v sub naught cosine 35. And then we could plug t in. Ew, that looks yucky. Maybe I want to solve for v sub naught instead. I don't know if I like t, because there's a lot of places to plug in t. So instead, maybe I'll solve for b sub naught. So b sub naught is gonna equal 90 over cosine 35t. Okay, I like that better because there's only one place to plug him in. We only have to plug him in there. T would have had to go. That looks good. So then we have 4 equals 7 plus 90 over cosine 35 t times sine 35. How can I simplify? I'm going to keep on writing to finish my equation, but is there anything that you guys see I can simplify in solving now? P.S. What procedure is this algebraically if I solve for one variable and I put it in another equation? Good. Just substitution. Is there anything I can simplify? Yeah. There's a t on top, t on bottom, isn't there?
Yeah, kill them.
I mean, kind of eliminate them, right? I could rewrite this a little bit and I could say, okay, 4 equals 7 plus, hey, what's sine over cosine?
Tangent.
Makes it a little bit prettier if I write 90 tangent of 35. But what am I trying to solve for? What's the only variable I have left? So I could go ahead and I'm just going to do a dot, dot, dot. T is going to end up equaling the square root of 4 minus 7 is negative 3 minus 90 tangent of 35 divided by negative 16. That works. We could flip all the signs, but whatever. Calculators can understand it. And what were they asking for in part A? Oh, never mind. Part A says write a system of parametric equations. That's it. Part B says find the speed. Oh, they don't want time. What do they want?
Speed.
The velocity. Yeah. So all we have to do to figure this one out is to go back to one of those equations once we have time. Let's go back to, I don't know, maybe the first one because he's shorter. And do 90 is equal to v sub naught cosine of 35 times that nastiness from right above. Now to solve for v sub naught, I'm going to go ahead and just divide the 90 by this whole shebang. Because I'm cool like that, I'm just going to go b. So moving him to the other side. There we go. It's nasty, but calculator can do it. And that's going to go ahead and get us our initial velocity of something, something yucky. What's part C say? Graph it. Graph what? Oh, the equations. Graph the equations. Because if I go back and just substitute that this is x and this is y, once I have my v sub naught, I can plug it in, and I can graph. And I'm going to see hopefully something like the picture that I kind of put up above. And it finally asks, find the time the receiver has to position himself after the quarterback releases the football. I want to show you guys one more thing on your calculator. So go ahead and get in par mode. I don't think this is something that we've figured it out.
Terrible.
Oh, come on. It's just a decimal-y thing.
No, that's all sucks. The whole.
Every chapter of Precalc, I think.
Soccer, if you kick a kick, it's going to be parabolic also. Well, I mean, it's probably going to be mostly flat, but depending on where you're trying to kick it.
Misty, every chapter in Precalc, I think the next one might be better than this, and every time it's worse.
I'm going to do a snazzy fraction you do because that keeps everything all honest. It's going to be 90 over bleh. I think I'm in radian mode. Kiddos, I'm trying to show you something on your calculator, see if you can help me out. I don't have to be helping you with 97.
We appreciate it, thank you.
Show appreciation by quieting down.
Wait, are you staying in degrees?
Well, I'm in degrees because it's 35. I was in radians, I had to switch it. So I have my 90 on top. On bottom, I'm going to have my nasty cosine of 35. I'm just trying to hopefully tell you guys you don't need to be scared of yucky expressions. If it's a calculator problem, we'll just throw it all in. It can handle it. I'm going to throw in a square root. And guys, what can I do with this? Make it pretty and make another fraction. See? Austin and David, shh. So I'm plugging and chugging. Jason, I can handle it. So plugging in the fraction. I'm just going to plug in this whole fraction. See, I have it all set up. It's nice and ready to go. -3 minus 90 tangent of 35. All over -16. Okay, you can grouse about having to hit so many numbers, but kiddos, the calculator's going to do all the work for you. Just go ahead and hit the enter, and then we know the initial velocity is 0.88. That works.
Oh,
If you want to be super snazzy and not have to write it over and over again, you can just stow it as a variable, like A, and then you can just hit A anytime you need to access it. But anyway, I have 54 unless you have Avogadro's number in there. So, I have 54.088. That's going to be my initial velocity. If I go to make my equations, because we need this in order to figure out when the football would hit the ground, how long the receiver has to get to it. Let's say the receiver wasn't there and wasn't able to get 4 feet. How much time does the receiver have from the point that the person let it go? How much time until that football hits the ground and it's a dead ball? That's the question. So then, we need to go ahead and put in our equation. We know V sub naught is, what was it, 54.088? Or A. Okay, well, that'd be a whole lot easier. I'm just trying to model for those people that didn't stow it. I have initial velocity, cosine of 35, times t. Make sure the t is outside the cosine. That's going to make a big difference. Then I'm going to go and graph my y1, so it's going to be 7 plus 54 if I can actually type 54, 54.088 times sine of 35, close the parenthesis, then the t, minus 16t squared. I have my parametric equations. All I had to do was find my V sub naught. It took some time, but I got it and plugged it in. Looking at my window, it kind of looks, oh wait, 90 feet. Hold on, 90. Zoom standard is not going to get me 90. So I need to go ahead and change my window a little bit. We can do zoom standard. It's freaking out a bit. But then I can go back here and say, okay, I have it in degree mode, right?
Yep.
I have my 54.088, I have my 7 plus. Making sure I typed it all in right, because something looks funny. 54.088 sine. Did I put minus 16 squared or did I put plus?
Is it because you didn't put the V
Put the
sub
sign
naught
in
times
the-
sine 35 in parentheses?
Put the 54 sign in parentheses.
It shouldn't have made a difference
Change
though.
it.
Because PEMDAS is going to multiply before.
Okay. Oh, okay. Wait, but the whole thing is big, by the way.
Oh, never mind, I got it. So then the window, we can go ahead and make the y max to be 100? I'm seeing the 90 feet. Maybe 120? Why are you going down? Does anybody see something funny that I put in? 35. Cosine of 35 times t. 7 plus 54. Oh, I didn't square my t. Oh, no wonder it's not a... Oh, no, I did square my t. No, I'm just going to clear it and do it again. Is anybody else getting a parabola? Is it just me that's getting something funny?
I'm just going a straight line down.
Yeah, mine is too. I changed the x scale to 30.
Maybe you're just back to it.
Well, I mean,
You didn't
your
put
brother
a T at the...
they're also getting the
Oh,
same
yeah, it's
thing.
not going to be good.
So
It's just you.
it's just me, it's bad? Is my badness affecting their goodness? I must be really bad, because a teacher is
You are very bad.
I am impressively incompetent. I will not deny that.
How was the flight?
It was pretty well. Thank you.
Pretty well.
It was pretty well.
0.2, that's good. That's why I don't want to see it. Since you can't even use the rubber.
The right grammar.
You can say it went well.
Ah, it's all about the window. Here's a struggle, guys. I was in degree mode, but the problem was I was saying that the ball would stay in the air 0 to 360 seconds. Jason, does it make sense that a ball would stay in the air 360 seconds before hitting the ground?
If you throw it far.
Which would be 6 minutes.
I would never go in.
But for anyone, 6 minutes? Are you going to throw a ball that's going to stay in the air 6
You know,
minutes?
there's God out there, so.
Okay. Any human. Okay, here's the problem.
I mean, Tom Brady's pretty good.
If we're thinking of time in seconds, 360 seconds did not make sense, and only looking every 7.5 seconds didn't make sense. But if we say, okay, it's bound to be 20 or less, I mean, it's probably going to be, what would you guys estimate? How long will a ball stay in the air for like a normal play if you're throwing it down the field?
3 minutes.
3 minutes.
10.
6 seconds.
I was thinking like 10 seconds. Jason's not helping even though he has experience. Anyway, so,
A minute 40.
a minute 40, no, the ball's not going to stay in the air for a minute 40.
I don't sport.
I was thinking like 6 seconds, 8 seconds, something like that. Okay. So 20 is an overestimate. I'm just making sure. How high is it going to go? I don't know. I'll just say 70 even though it's an overestimate. There we go. All right, that looks a lot more normal. I was reading that my time range was way off. Now kiddos, hold on. We're trying to estimate. Oh, hey, wait a minute. When is the ball in the ground?
Let's find out.
When it's on the axis, right? So there's this cool feature, isn't there, in every single second trace menu to find the 0? Oh.
Wait.
Parametric is different.
Just do value and then it says.
So why don't we just do trace and say, okay, hold on, let's go see when the 0 is. It's the best we can do.
Give you a precise value.
Except my y is a negative now. That's not very helpful. Less than 5 seconds, less than 4 seconds, less than 3 seconds. There he is. So 2.5 seconds maybe. We could do trace and we could try 2.75 maybe. Oh, it's negative. So it's somewhere between 2.5 and 3 seconds. We could get it a little more precise, but the problem is, guys, this is why it said approximate 2.6 seconds. Oh, it's still a negative.
3.
Maybe 2.4 seconds. You have to go lower. Still a negative.
Well,
2.2 seconds.
Just do 2 seconds.
Okay, that's pretty close. 2.1, 2.2. Like, so they have basically 2 seconds to get to the ball. Since it was snapped. Not since the beginning of the play, but since it was released. Alright, anyway, cool kids, I wanted to let you know a few things, because in parametric and polar mode, even though there's a lot that you can do, this little menu that you're used to having all these options, they're no longer there. They're no longer there.
calculus stuff.
So yeah, you have to kind of, I don't know, when you go to actually using those modes in more detail, you're actually going to go back and forth between parametric and function, because function you can find maxes and mins and zeros and intercepts. So you're going to go back and forth. But we're not having to do anything here that complicated. Okay, section 10.7, change your calculators to polar mode.
This is sad.
Starting 10.7 today, finishing 10.7 tomorrow. Yeah, 10.6 we checked the homework, that was just a word problem.
That homework made me sad.
How many more sections are there gonna be?
Tyler's saying. are you
After
trying to
10
figure out-
section, well, if you let me talk, that'd be nice. After 10.7. Once again, if you let me talk, good. After 10.7, we have a quiz, then we go to chapter 12. Chapter 12, we'll get anywhere between 1 and 5 sections.
Oh, alright, well, I'm done.
Oh, just give me that stuff, isn't it?
I have 2 more pages.
I'll have fun with that.
I have to start
But some people have
stapling.
been very creative, and they like make little tabs, and like they cut their papers up their little tabs, and then they like glue it on the other ones, so they have other papers to jump on.
Yeah, I've done that.
Better than stapling on top. Alright, section 10.7, guys, there's a lot of things that we need to talk about today just to get an introduction. We only have 10 minutes, so here we go. That was an early word problem though, and I wanted you to see that parametric in that second trace menu doesn't have all the options we used to. Okay, so what's new in polar equations? In rectangular equations, you have an ordered pair and it stands for x and y. But in polar equations, you have an r and a theta. There's still going to be 2 numbers. But what's going to be different is what those numbers represent. R, if you guys see all the circles down below, R is going to be what we call a radius. theta is gonna be an angle of rotation. And we've seen these variables before, we just haven't seen them written as an ordered pair before. So we have r and we have theta. R is for radius, theta is for angle of rotation. R is for radius, theta is for angle of rotation. And then this little picture off to the side is pretty important as well, in the sense that we've renamed a few things, like what we used to call the positive x-axis is now called the polar axis. You guys can see that label over here to the side. What used to be called the origin, even though it's labeled with an O, is actually now going to be called instead the pole. As in the North Pole, South Pole, think about it that way. And the radius, well, it's not exactly the radius of one circle. The radius is the directed distance. The distance out along the diagonal. So not out along the horizontal, not out along the vertical. R is the distance out along the horizontal. But there is a reason I call it radius, and we're going to see that down below. There is a reason I call it radius, and we're going to see that down below. Now kiddos, down below, I realize that most of you are like, I really don't want to draw that. So hold on and let me show you what I want you to draw. Ready? I want you to draw a y-axis, which is now technically called the pi over 2 line. I want you to draw a y-axis, which is now called the pi over 2 line. And I want you to draw the x-axis, which is now called the polar axis. And I want you to trace, do you remember how we made 45s, just on paper? 45 degrees, how did we do that? Didn't we cut each quadrant in half? I want you guys to draw a line cutting each quadrant in half. So making the 45s in the first and third quadrant, and then cutting the quadrants in half for the second and fourth. Okay? So little dotted lines I'm showing you. I want you to show me 45s and 135s. And that should extend to the other two quadrants as well. I'm not going to make you draw all of these. There are things called polar papers that you could technically print out from someplace. There's I think one website called mathgraphs.com. These are standard polar graphs. But I also want you to try to, just real quick, remember 30 is a little bit below 45 and 60 is a little bit above. I want you guys to also try to trace the 30s and 60s in each quadrant. Just do one long line. If you have a straight edge, you can be using that, a ruler or your ID card. So what's missing are those awkward, well, they're not awkward in the picture, because in the picture it's perfectly sectioning my circle. But we're not used to going every 15 degrees, because we aren't used to having these extra guys, because they're not mean circles. So you just leave them off, that's okay. And if you were to have to use them, you could just approximate that 105 is in between 90 and 120. So we just basically traced the angles real fast, or you guys made a quick sketch of like the unit circle, all right? Now, I want to show you how to graph one polar point. No, wait a minute, what are you missing? Yours looks pretty close to mine, except what's very, very different.
Circles.
Yeah, there are no circles. Now, I don't want you to make circles, but what I do want you to make is tick marks. And I want you to go on the x-axis out 1, 2, 3, 4, 5, 6, 7, go out 8 on the x-axis. Go up 8 on the y-axis. Back 8 on the x-axis. I probably should be using the new name of polar axis. And then down 8 on what used to be the y-axis and is now called the pi over 2 line. Okay. Now, let me give you a point. Get your tick marks. You don't have to make the circles. If I was to ask you to graph the following, and I was to say, okay, I want you to graph the point. Let's see. Let's do 2 45 degrees. Okay. Where's the 45 degree line? Right here, right? How do you go 2? Do you go over 2? Do you go up 2? Or do you go out 2?
Oh, ouch.
That's why it's called a radius. It's a radius of one of those circles. So here's what I want you guys to think of. What I want you guys to think of is there's the 45-degree line. I want you to think of connecting in a circular pattern the two tick marks, the two tick mark on the X and the two tick mark on the Y. If you were to make a circle, if you were to rotate, where those two intersect, the 45-degree angle and the circle with a radius of 2, that's where your point, let's call them A. That's where your point A would be. Does that kind of make sense? So the 45-degree, and then we're going out to in a diagonal fashion along the angle line. And since you guys don't have circles drawn, you can just connect and you can rotate the 2 tick mark on the y-axis and the 2 tick mark on the x-axis. Rotate, pretend like it's a circle, and then you can connect and make your point. Let me show you what's a little different. What if I was to show you -3, 90 degrees? What happens when the radius is negative? Well, where's 90 degrees? Right there, right? In between the first, second quadrant. So if this is 90 degrees, and if we're supposed to go out 3, positive 3 would be right here. You're going 3 towards the 90 degrees. Negative says, no, I'm backing up the other way. So instead of going towards the 90, you're going directly away from the 90. So my point is going to be 1, 2, 3 in the opposite direction. Does that make sense, kind of, guys?
Yeah.
Positive radius, you go towards the angle. Negative radius, you go away from the angle. So let me go ahead and give you an example, and let's see where you guys are going to put this one. What if I was to say graph 5, 210 degrees, which is 30 degrees past 180. Where would you guys put point C? 5, 210 degrees. How'd you guys do?
Yeah.
Did you get it?
That's my certain.
And if you're a little confused, remember, go out to the 5th tick mark and connect the 5th back on the X with the 5th down on the Y. Where they connect, that's going to be C. We're 210. And that circle connects C. How about this one? How about 0, 330? Where's that going to be? Here's, oh, because you're not going anywhere. Okay, so that's D. My question, what about 0, 47 degrees? Oh, how about 0 and -30 degrees?
Obviously, you're trying to make a point.
Yes, I'm trying to make the point.
Because you said point.
How many different, and Caleb explained it. So, question. Here's something a little weird. In function or rectangular coordinates, one point is one location. In polar, one point is one location, but there might be infinitely many points that have the same location. Kiddos, tomorrow our goal is to learn more about polar and some of the different ways to work with their equations and their points, and then we're done. There's a lot more polar in 10.8 and 10.9, but we're just going to get you an introduction so that you've seen it, and we'll move on into pre-calculus. Let's get closer to calculus. Bye, guys. This is pre, like, physics.
I'm gonna keep this stable so I can play with it during chat.
That doesn't sound safe. That sounds bad.
No, staple.
That's disturbing.
Let the boy play with
It's
the
not
staple.
sharp enough, I can't inflict pain on myself.
Good thing that's recorded.